translator, and 8 PTDS 12K projectors. I had 2 hours to answer 19 questions, but I spent 38 minutes doing moaning and groaning, which meant I only had 4 minutes to answer this question. Show that a triangle with sides that can be written in the form n squared plus 1, n squared minus 1, and 2n, where n is greater than 1, is right angled. And this is what I wrote. Start the clock. If a triangle is right angled, one of its sides will be 90 degrees and will therefore follow Pythagoras' theorem. Pythagoras said that a squared equals b squared equals c squared. To put it simple, if you draw squares from the 3 sides of a right angled triangle, then add together the area of the 2 smaller squares, this will be equal to the area of the larger square. Now, this is only true if the triangle is right angled. Come on, Judy, get up there. Come on. Yes. The A-level question is the algebraic formula for making right angled triangles. N squared plus 1 is the largest number in this equation, which makes it the hypotenuse, which is the longest side of the triangle. Now, to find the area of the square, you must multiply the length by the width. So the area of this square is 2n times 2n, which equals 4n squared. The area of this square is n squared minus 1 times n squared minus 1, which equals n to the power of 4 minus 2n squared plus 1. Now, if we add these 2 squares together, we get n to the power of 4 plus 2n squared plus 1. Now, we need to find the area of the square on the hypotenuse, which is n squared plus 1 times n squared plus 1, which equals n to the power of 4 plus 2n squared plus 1, which is the same term. So, the area of the 2 smaller squares is equal to the area of the larger square. So, all my squares